That's a good reminder. That thing is.
Parabolas.
Yeah. I said that.
I'll talk about that. And then again, that's good. I get new ones.
I can listen on the end.
And like, you know, I will build something.
I don't think catchphrases. It's a smaller.
Yeah. Oh,
It depends on where you're going. I like it because I like mine. That's against.
Did you know? Hey,
universal. I'd like
Okay, we're going to review parabolas today, but also continue to work on equations or graph equations that are maybe not as complete as the one that we started with last Friday. So we're on the same topic. It's just the equations need a little bit more work before we can pull all the information from the equations. So let me just do a quick review. This is from one of the pages attached to your calendar. We talked about how parabolas can either open either vertically up or down, but could also open to the right or to the left. But there are some important distinctions here. One is that if your parabola is either opening up or down, your x is what's squared, okay? And then your y is the one that is to the first power. And then if your parabola is open to the left or to the right, it's the y that's being squared, and then your x is to the first power. There's also this important p-value, and p-value allows us to get to find that distance between some important locations on the parabola. You have the vertex. Vertex is the lowest point, or it's the most extreme point on the parabola. In this case, it's the lowest point. And then we talked about how vertex to the focus is p units away. And then vertex to the directrix is also p units away. And then we have to basically use the formula to help us find that p-value. And once we find that p-value, we can find that it's all going to be right along the same line. Okay. Either vertically above each other or horizontally across from each other, just depending on where your parabola is. Your focus is always inside the parabola, and your directrix is always outside the parabola. Okay. Why don't we do one problem before we jump into all these equations, all this different types. So let's try number 4. We didn't do number 4, right? On page 3. Did we do number 4? No. Okay. All right. So okay, we'll walk to number 4. So we see y plus 2 squared equals negative 8x plus 2. Now y is being squared. So is this parabola opening up down, or is it opening left right? Left right. So we know it's going to be one of either left or right. And the way that we can tell either left or the right, we look at what's on the other side. Is it a negative or is it a positive? And because it's negative, we associate negative with left. We associate positive with right. So we know that this parabola is going to open this way. And we're just trying to get some very general information before we dig into all the specifics. So if your parabola is opening to the left, you know that your vertex is going to be whatever that point is. You know that your focus is going to be somewhere inside. You know that your directrix is somewhere outside with a line going through it. And then you know your axis of symmetry is going to cut your parabola in half. Okay, so you know that after everything is said and done, this is going to, it should look like what we've, just briefly gathered. Okay, so first thing, we want to find the vertex. So the vertex comes from your parentheses, and you're going to follow the H, follow with the K. The H is always with the X, and the K is always with the Y. And then you always have to take what sign? Take the opposite, right? Opposite sign, right? So instead of 2, 2, you're going to say what? Yeah, -2, -2. So opposite sign. So if it's showing negative, then you got to change to the positive. So just know that anything that you're putting in or outside of parentheses, you're always changing the sign along the way. Okay, so I'm going to go ahead and graph that order pair, -2, -2. Okay, so here's my order, here's my vertex. I know my parabola is going to open this way, but I'm not going to graph it just yet because I'm going to gather some more information so I can get more accurate. But I do know that my axis of symmetry is going to cut my parabola in half. So I know it's going to be a horizontal line. I'll put that horizontal line here. And what's this equation here? Y equals, yeah, any horizontal line is always a Y equals. Your focus is always P units away from your vertex, but we got to find that P value first. So what we do is we look to the equation, okay, and we look to the formula. So we know the formula is y minus k squared equals 4p x minus h. So you know that this 4p is always going to be equivalent to this number that you see outside the parentheses. So we're always going to set these two equal to each other so that we can find our p-value. Once we find our p-value, then we know how far to move to get to these important points around the parabola. Okay, so we set 4p equal to -8. Divide by 4p equals what? -2. Hey, we already took care of the negative. We already know it's going to open to the left. So we just have to count the fact that it's 2 units away from the vertex to get to your focus. Your focus is going to be to the left because it's going to have to be inside the parabola. So I'll go 2 units to the left. Put an F for focus. Go ahead and identify that order pair. Okay, and then you know that 2 units away on the other side of the vertex is going to be a point where your directrix is going to go through. So you're going to plot that point. Now the directrix is not the point. The directrix is going to go through that point. So as long as you know, if you plot that point, it just helps you know where to draw your line. Your line is always going to be perpendicular to your other dotted line, which is your axis of symmetry. So your directrix is right along that y-axis. What's the equation of the y-axis here? X equals 0. Okay, focal width, there's a formula here. Focal width is the absolute value of 4p. P is -2. So if I just put -2 in for my p-value, I get -8. -8, absolute value of -8 is 8. So I know that my focal width is going to be 8. So that means above and below, I want the full length to be 8, which means the focus is in between. If I'm in between, if I want to count 8 units total, I'm only gonna count what? How many units up? 4 units up. Yeah, so I'm gonna go 4 units up, go 4 units down, because ultimately I want the entire length to be 8 units long. So I don't want to go up 8 and down 8. If I do, then it's too wide. Then it's 16, right? We only want from end to end to be 8 units. So from the focus, you'll go up 4. From the focus, you go down 4, and that will give you a full distance of 8. And then once you have your focal width, then you know how wide to make your parabola. Right? It kind of helps you shape your parabola a little bit, gives you a little more guidance. And so that's what we're able to do before the break. Right. All right, so any questions here? So today, what we're going to do is we're going to be working on equations that are not quite set up. So we have to maybe complete the square, or we have to rearrange and factor out the GCF. So because our goal is to get it to look like this, because this is the easiest form for us to gather the vertex, the p-value, and that's what we want so that we can move forward. So let's look at day 2. Okay, we have this process called completing the square. You've learned it before, but I'll go through it step by step and kind of show what we need to do to get our equation to be in the proper form. So here, what variable is squared? Y is squared. So you know that you're ultimately trying to make this look like this form. Okay, you know what your goal is. You're trying to make it look like that y minus k squared. Right. So really, what we want to work on is the y variable. We want to get that y variable to factor nicely. The x, we don't care about. The x we can just push to the right side. We'll deal with that later. But you see that number 1 is not quite in that proper form. You want that parentheses around the y. But to do that, we have to kind of rearrange the equation a bit. So let's get the y's together. Okay, so I'm going to subtract the 2y over. And I only want the y's on the left side, okay? Because that's what I want to do, make progress with. I want to get that y equation, y variable worked out so that it comes out cleanly like that y minus k squared. So I'm just going to kind of group the y's together. Once I have the y's together, everything else is going to go on the other side. Okay? All the leftovers goes on the other side. So I'm going to subtract the 12x, but the 13 is already on the right side, so I'm not going to change the sign. I'm changing the sign of the 2y to move it to the left. I'm changing the sign of the 12x to move it to the right, but the negative 13 is already on the right side. So our goal is to try to get this to be in the proper form. Okay. So in order for that to be in the proper form, we're not going to factor out the y. If we factor out the y, it's not going to quite look like that parentheses squared. What we want to do is we want to complete the square. We want to create a trinomial that factors out nicely so that it creates this binomial squared. So how do we do that? Well, we make it y squared minus 2y plus blank. Okay. And we're going to figure out what to do with that space. But we want to find a nice number that will allow that to factor nicely. But I don't want to change the overall equation. So whatever number that I'm eventually going to fill that in with, I'm going to have to make sure I keep it balanced on the other side as well. Make sure you always do it a plus space. It's always going to be a positive number that you're going to put inside that space.
You just add 0.
Huh?
Why can't you just make it +0?
I could, but if I put +0, it's not going to help me get any closer to what I want to get to. So I'm trying to get it to be a binomial squared. But whatever number we find, I can just go ahead and make that number show up on the other side, because I know that if I add 13 on the other side, I'm not changing my overall equation. Yeah.
What is k? Like,
Right. K is the y value of the vertex. So once we find the vertex, it's the y value of the vertex, and h is going to be the x value of the vertex. Okay. So how do we find that value for the space? Okay, so here's the formula. The formula for that space is b over 2 squared. Okay, that's what goes in that space. And any idea what the b value is? Yeah, yes, -2. It's the number that's attached to your linear variable. So 2y, and we only want the number, so it's only 2. Now, I don't really care about the negative, and the reason why is because I'm going to square it. So I'm just always going to take the positive number. Okay. So if I put 2 into the formula, which is my b value, what's 2 over 2? 1. What's 1 squared? Still 1. Okay, so 1 is going to go in that space, but I don't want to just add 1 randomly without making it balanced, because I don't want to change my overall equation. So whatever I add to one side, I'm going to add to the other side, making it balanced. So now this becomes a factoring problem. Okay, the question that I'm going to ask is, we're going to factor this. What multiplies to be 1 and adds up to be -2?
-1 and -.
-1 and -1. It's always going to come out to be the same numbers, right? If I double check that, -1 times -1 is 1, -1 minus 1 is -2. That's perfect. So I'm going to say y minus 1 minus y minus 1. Okay. That is the factored form of y squared minus 2y plus 1. Okay. Any questions with that? Okay. Now, what if I merge that together? What's y minus 1 times y minus 1? That's the same thing as saying what?
Y minus 1 squared.
Okay, so that's why we do this. We're trying to get it to look like this y minus 1 squared, so that it looks more like the form that we've been working with on day 1, and that way we can pull the k value that we want. Okay, so that's the hard part. The hard part is trying to get that whatever that variable square to be in that proper form. And now the right side, we'll do a little bit of cleanup and do some GCF, but the hard part is done. All right, good so far. Okay, now let's work on the right side. The right side, I'm going to combine some like terms here. So -12x minus 12. And you're always, well, you should always look for a GCF. Okay. And what's GCF? -12. Okay, so I'm going to factor a -12 out. If I factor a -12, that means I'm dividing everything by -12. If I divide everything by -12, let's figure out what goes inside the parentheses. -12 divided by -12 is just positive x, yeah. And then -12 divided by -12 is positive 1. Okay, always double check. Okay, distribute that -12 through. Make sure that you can still go back to where you came from. If I distribute this through, I get -12x minus 12. That's perfect. That's my standard form. So standard equation, I can just rewrite that, or you can just point to it. So now from here, everything will feel familiar from last Friday. Okay. But the additional step that we're doing today is getting it into standard form by completing the square. Okay. Now you can find your vertex. Now you can, go through all the other steps. Okay, so let's finish out this problem. Okay, so y minus 1 squared, which direction is it opening with a negative here? Y is squared and is negative, opening to the left. Yes, going to open to the left. I'm just going to draw a picture. It's not accurate, but I just want to be able to visually see where all the things are going to be, right? So your vertex will be here, your focus will be here, your directrix is here, and your axis of symmetry is here. All right, so when everything is said and done, everything should be should match in terms of where things are to each other. Okay, vertex. What's the vertex? Okay, remember, you're always going to follow the x first and then get to your k. We've got to change the sign, so we've got to start with this number here. -1, 1. Good. -1, 1. Right? To find the p-value, you're going to set the number outside the parentheses equal to 4p. Right, so you're always setting these equal to each other to solve for your p-value. Okay, 4p equals -12. Therefore, p equals what? Let's go ahead and get that vertex drawn. We can go 3 units to the left and reach our focus because we know it's got to be inside the parabola. So it's nice to just have something to look at so that you don't feel like that you don't have a foundation, right? Because if you don't have a picture in front of you, you may be confused as, okay, where's my focus? Is it to the left? Is it to the right? But if you have a picture in front of you before you do, you can kind of put, things in place without too much trouble. Okay, so 3 units to the left. 3 units to the right. But this is going to be a line. Okay, the point is just to help guide you, but this point is really not important. You're not going to identify that point. That point is just to help you know where to draw your directrix. And then your axis of symmetry is going to split your parabola in half. It's going to go through all the points that you have there. Okay, so now you're just identifying what you've plotted on your graph. Okay, focal width is always absolute value of 4p. My p-value is -3, so 4 times -3 is -12. I only want a positive version of it, is 12. So I know I have to start at the focus and move up and down, but am I going to move 12 units up and 12 units down?
6 and 6.
Yeah, just 6 and 6, right? I'm starting in the middle, so I'm going to just go halfway so that I can, from end to end, I want to be 12, but I don't want to be 12 from middle to the end. Okay, number 2. We can tell that's done in standard form, so it doesn't have all the parentheses that we would like to see. But what variable is squared? X. So that's going to be your goal. That's your initial work. Try to get that X to be cleaned up on the left side. So I'm just going to put the X's together. It's already together, actually, so I can just go ahead and. But that's the only thing that I want on the left side. So what do I need to move? What's there? Yeah, that 25. We want to get that out of the way just to get it a little bit cleaner. So let's go ahead and subtract 25 over. Now, we want to create that space in order for us to factor that X. So I'm going to go ahead and add space to both sides. Okay, so we're going to figure out what goes in that space. What's our formula again? B over 2 split, yeah. Okay, my b is always the number in front of my x or my y. In this case, it's the x. So yeah, I don't want to choose this 8 for the y because that's not what we're working with, right? We're working with the variable that has the that we're trying to complete the square for. So 10 is the b value. 10 over 2 is what? 5, and then 5 squared is 25. Okay, so you can put 25 into both your spaces, and they're in your space values will always be positive numbers. Always positive. Okay, so we ask ourselves, what two numbers multiplies to be 25 and adds up to be 10? 5 and 5. You're always going to get the same two numbers because it's going to be a nice binomial squared. And that's going to allow you to see, okay, I can merge those parentheses together and just make it x plus 5 quantity squared. Okay. And then the right side, now we're just trying to clean things up, take out the GCF. Yes.
Does it matter that X is on the left?
That's what we want. Yeah. So, we're always trying to decide which formula we want. Do we want the X on the left or Y on the left, depending on what's squared, right? So whatever squared is what we want to put on the left to kind of make it match our formula.
Okay.
Yeah, whatever is squared is what we're going to target on the left side. Okay, so what's our GCF on the right side? -8. So factor -8 out. If it helps, you may want to put a divided by -8 so you can kind of see what is going to remain in the parentheses. So what's inside the parentheses? Y, yep. Y, because -8's canceled out. And then what's 24 divided by -8? -3. There's my standard equation. Okay. X is squared, so is it parabola up, down, or left, right?
Left, right.
Well, X is squared.
Oh, up, down.
Up, down, yeah. So X squares up, down, and then we gotta narrow it down. Is it up or is it down? That negative will tell us down, yeah. So we know parabola is down. Let's do a quick sketch so we can kind of just make sure we know where everything is going to be, kind of create a map of what we want our graph to look like. That'll make it a lot easier when you're trying to figure out, wait, am I going left or right with my p-value? And what am I trying to find, right? If you didn't have that really quick sketch, you can kind of work towards that picture. Okay, we want to find the p-value.
Mr. Ian,
Yes.
why can't you just factor it at the beginning instead of completing the square?
If you factor at the beginning, you're right. This ends up being a perfect square already. But it's not always going to come out as clean as that.
Okay.
But yeah, you're right. If you notice that, oh, that's already a perfect square, I'm going to go ahead and factor. I think that's great. But I think this is more of a coincidence. We can't expect that to occur every time. Yeah. But you're right. It does feel like we're doing redundant steps because we ended up with the same thing there anyways. But I also want us to make sure that we understand that, you know, most problems are not going to be quite ready for you to complete the square. So if we go through this step, we can always ensure that we can find the number that we need to get that factor out perfectly. Okay. Okay, vertex, what's our vertex? -5. So to find your p-value, set the number, the factored value outside of your parentheses equal to 4p. So I know I'm going to move up and down to get to my focus and my directrix. Pause it, fine. Okay, number 3. Okay, what variable is squared? X. So we know we got the x on the left. Now, what's different about this equation that we haven't seen before?
On one.
Yeah, that x squared has a what in front? That coefficient, right? Typically, we don't like to deal with that, or we're not expected to deal with problems that have that coefficient. So what we can do is we're gonna try to get rid of it. Okay, so I know that if I just divide everything by 3, I could get that x squared down to a coefficient of 1, and then I can go through complete the square that I need to do. So we'll divide everything by 3 and just begin the problem from there.
I mean, like, there's a problem like that, but like not everything's divisible by that number.
If it's a parabola, it will be, yeah. I won't give you problems where, I mean, if it's not divisible, then you have to deal with fractions with the constants, but I won't let you do that, yeah, not with ones that. If I want you, yeah, if I want you to complete the square, it'll have to come out cleanly. 87 divided by 3. Sorry, minus 10, yeah, minus 10y. Minus 6x plus 29 equals 0. Okay, so let's, we know the x is squared, so let's go ahead and group the x's on the left. Okay. Make sure everything is in its proper place. Does that look good for everyone? Okay, so now we got to do the work that allows us to complete the square with the x. So I'll go ahead and add a space to both sides of the equation. B over 2 squared is my formula. What's my b value? Well, initially b value is just 6, right? 6 divided by 2 is 3, and then 3 squared is 9. Once you are able to fill in that space, it should factor out very nicely here. 1 multiplies to be 9 and adds to be -6. Close. -3 and -3, right? Okay, so. Yeah, multiplies to be 9, adds it to be -6. And then the right side, we can, well, the left side we can clean up even further. And the right side, we're just gonna combine like terms. DCF. Divide everything by 10. So now this feels like a starting point for yesterday's problems, right? And from here, we're actually going to get a decimal, but if you just follow your steps, you can just sketch your graph the same way as before. Just that a p-value may be a decimal, but it's okay. You can just estimate it on your graph. Okay, so finish it off, and then I'll work alongside you guys as you guys are doing so well as well. Oops, sorry. Wrong place. Y equals. Okay, let's do one more, but let's just get it down to the standard form. Let's just practice the process of cleaning it up and getting the standard equation, and then we'll pick up tomorrow. So let's do page 5, number 1. Okay, what variable is squared here? The y, right? So I know my work is going to be with the y. This feels a little bit backwards. That y is on the right side. I'm just going to rewrite it with that y on the left. Just feels more familiar when we can just have everything lined up the way we want to. But what's in the way of our, yeah, we don't want that three there, otherwise it's hard to complete the square. So we'll divide the three out. So divide everything by three, and then we can start with a clean slate. B over two squared, what's my B value? Two, yeah. Two over two is one. One squared is one. Okay. So let's factor this. One multiplies to be one and adds up to be two. What two numbers multiplies to be one and adds up to be two? One and one, right? You're always going to get a duplicate. That's the whole purpose, to try to get that duplicate to be merged together. Okay, any questions? Okay, so tomorrow we'll do some more practice to complete the square, but we're also going to talk about problems that are where it's like a word problem, where you have to gather information with a bunch of information that is provided. So we'll do these more problems tomorrow, but we'll get some more practice with completing the square. We'll spend another day on parabola before I move on to circle. Okay, look at your phones.
We started on kind of events.
On, you know,
But it's.